Hi everybody, happy Monday. Welcome to our first day of online learning. In a few moments we're going to go ahead and get started with our first video lesson, which is going to be a review of CPC-TC. While I'm going through today's lesson, I do want you to take some notes. So if you have a printer at home, you can print out the copy of the blank notes that I'm going to be going through. If you don't have a printer at home, you can just take notes on a separate sheet of paper. Just as an FYI, I do have 2 dogs at home, so they are very likely to bark during the video at some point. So I just wanted you to be aware of that in case it happens. So first proof we're going to take a look at today, I've already filled in the given information. I marked up the diagram to show that we have a pair of parallel segments, a pair of congruent segments, and then the last piece of information says that BF is congruent to CE. And since in the diagram those segments overlap a little bit over here, I redrew the triangles separately down below, and I'm going to mark up the same information just on this part where I redrew those triangles. So we have still the pair of parallel segments, we have the pair of congruent segments, but now it's going to be a little bit easier for me to tell that BF is congruent to CE because those segments are not overlapping anymore in this diagram down here. So remember our game plan for problems for proofs using CPC-TC is we first want to prove a pair of triangles congruent. So because in the diagram there's only 2 triangles, it is obvious that those are the 2 triangles we want to prove congruent. And at the moment, we have 2 pairs of sides congruent in each of the triangles. We have 1 pair of tick marks, 2 pair of tick marks. So if we want to prove the triangles congruent, we either need to start proving a pair of angles congruent or the remaining pair of sides congruent. So remember, when we are given that we have parallel segments, it is going to tell us that we have a pair of congruent angles. So I have a highlighter I'm going to use to, in the picture, highlight the 2 parallel segments, and I'm going to find a transversal that connects the 2 parallel segments so that I'm looking at a Z or an N shape. So the transversal is this one diagonally that I just highlighted. And remember that the angles that are going to be congruent are in the corners or the crooks of that Z or N shape. So for my next step, I'm going to name the pair of angles that I just marked up as being congruent. So you could go ahead and name these angles just with the vertex. So there's only one angle F and one angle C in the picture. So I could say that angle F is congruent to angle C, and the angles that are formed here are alternate interior angles. So I could say, because of alternate interior angles theorem, angle F is congruent to angle C. So if I go down to this diagram where I redrew the triangles separately, mark up those same angles, I do have enough information to prove the triangles congruent. I have 2 pairs of sides congruent, and I have the included angle. So the triangles are going to be congruent by side, angle, side. Remember that we do not have the triangle congruency statement up here next to the word prove. So we have to go ahead and name the triangles ourselves, and when we do this, we have to make sure that we write the vertices in corresponding order. So I'm going to go ahead and name the first triangle any way I want to. So I'm going to go ahead and name that triangle AFB. So I went along the segment with 1 tick mark on it to the angle I have marked up, and then the vertex or along the side here with 2 tick marks. So A, F, B. So when I name the second triangle, I want to do that same order. So I would go D, C, E. because that allows me to also go along the segment with one tick mark to the angle I have marked up, and then along the segment with 2 tick marks on it. So in terms of our game plan for these proofs, we did prove a pair of triangles congruent. Next, after we prove triangles congruent, remember we always use the acronym CPCTC, which stands for corresponding parts of congruent triangles are congruent. And this is going to allow us to say we have a pair of corresponding angles congruent or a pair of corresponding sides congruent. So if we look at the proof statement is not proving a pair of sides congruent, it's proving a pair of sides parallel. So what I have to think about is if I want to prove side AB parallel to side EF, if I go into the picture and highlight AB and ED, sorry, not EF, AB and ED, if I highlight those are the segments I want to prove parallel. I need to find a transversal that is going to connect them. So now in purple, I have another Z or N shape. And what it's going to be for our next step is I want to prove the angles in the corners of that Z or N shape to be congruent. So remember, when we're using CPCTC as a reason, it has to go along with you either proving angles congruent or sides congruent. And those angles or sides that you're proving congruent have to be corresponding sides in the triangles you just proved congruent, or corresponding angles in the triangles you just proved congruent. So the angle pair that I'm going to prove congruent is going to be angle ABE is congruent to angle DEC because of CPCTC. Now, because I have that pair of angles congruent, I can now say that these 2 segments are parallel. Now, there's 2 different ways that you can write the reason for this. If you're a names person, the way that we've been writing that is the converse of alternate interior angles theorem. If you want to do kind of like the little picture sentence we've been doing, if we have alternate interior angles congruent, the little arrow means then we have parallel lines. So either one would be acceptable. You only need to write one reason, either the name or the little sentence with the arrow. Either one would be acceptable there. So we're going to move on to the next one now, which I also have filled in the given information. So I'm told that O is the midpoint of DB and AC. So I'm given a key vocabulary word there, midpoint. So I want to use the definition of midpoint to say I have some segments congruent. So O is the midpoint of segment DB, so it has to split DB in half. So I would know then that DO is congruent to BO. I also know that O is the midpoint of AC. So AC is here. O has to split that segment in half. So additionally, I would know that AO is congruent to CO. Now, the tough part about this second proof is if you look at the diagram, there are a whole bunch of triangles. There's like 4 small ones. There's other pairs that are a little bit larger that are overlapping. And because the proof statement isn't any longer prove triangles congruent, This diagram is a little bit harder to say what triangles are we proving congruent. That's our game plan. First step is we need to prove some triangles congruent. So how are we going to do that, and what triangles are we going to prove congruent? So I've marked up the picture with the information I know from the word midpoint. And now, if we look at the proof statement, we want to prove that segment AD is parallel to segment CB. So eventually, we want to get to a place where we can prove these two segments parallel. So what I'm going to want to do is prove this triangle congruent to this one. Because this triangle and this triangle both have two sides with one tick mark, a pair of sides with two tick marks, and they contain the pair of sides that we want to prove parallel. So if I just like lightly highlight these two triangles, it is these triangles that we want to end up proving parallel to one another. Or sorry, congruent to one another. Those two triangles we want to prove congruent to one another. So we have two pairs of sides congruent. We need a little bit more information to prove the triangles congruent. And if you notice, we have this segment and this segment overlapping to form the X. So remember, when we have the X, opposite sides of the X, we have vertical angles, and vertical angles are always congruent. So for step 3, I'm going to say that angle DOA is congruent to angle BOC because vertical angles are congruent. We do need to name these angles with 3 letters because there are multiple angle O's in the diagram. So I am able to go ahead and say the triangles are congruent now. So I'm going to name the first triangle any way I want to. I named it DOA, going along 1 tick mark to the arc mark and then along 2 tick marks. So when I name the second triangle over here, I want to make sure I go in that same order. So I would go BOC. And the way that we're going to prove the triangles congruent is by side angle side. So we've proved the triangles congruent. After we prove triangles congruent, we're always going to use CPCTC. But remember, that goes hand in hand over here with a statement where we're stating angles are congruent or sides are congruent, not that segments are parallel, which is what we have over here. So again, I highlighted the 2 segments in purple that we want to eventually prove to be parallel. So what I need to do is I need to find a transversal that is going to create a Z or an N shape. There are actually 2 that you could choose. You could choose to highlight DB as your transversal, or you could choose to highlight segment AC as your transversal. So there is a choice here to make which transversal do you want to outline to find the pair of alternate interior angles. I think I'm going to decide to highlight DB this way. So the angle pair that I want to say is congruent due to CPCTC are the angles here in the corner of the Z shape that I highlighted, or the N shape. So that's going to be angle ADB is congruent to CBD, which are the 2 angles I marked up congruent here in purple. Because again, we have a pair of alternate interior angles congruent, we can go ahead to say we have a pair of parallel segments. And just like step number 5 up here from the first proof, you could either use the name or the little sentence with the arrow. That is a choice that you can make. For this one, I'll go ahead and name the theorem. And there is our second proof. So what we're going to do now is flip over to the back. And we're going to go through a couple of proofs on the back. So I again filled in the given information. Now, the two problems on the back, if you look at the given information, it gives you a pair of triangles that are congruent. So if you look at the diagram, I've outlined the two pairs of triangles that I'm told to be congruent in red. So triangle YFR is congruent to triangle YFL. That was given to me. So I have a pair of congruent triangles, and if I look at the proof statement, I want to prove I have a different pair of congruent triangles. I want to prove that YPR is congruent to YPL. So first thing that I want to do is, since I know that I have a pair of triangles congruent, I didn't have to prove a pair of triangles congruent. I was given a pair of triangles congruent. I want to use CPCTC to name some congruent corresponding pieces in these two triangles. Now, altogether, there should be 6 pairs of corresponding congruent parts now. You could name all 6 if you want to, but we're not going to need all 6. So what I recommend doing is highlighting the triangles that you are given to be congruent, and then highlighting the triangles you want to prove congruent. So I'm using blue to highlight the triangles that I eventually want to prove congruent. And I'm going to look at the diagram now and see if any sides or angles completely overlap. And they do. So side YR was in the red set of triangles and the blue set, along with YL was a side in the red triangle and the blue triangle. I also have angle LYP and angle RYP. These two angles here fell inside of the red triangle and the blue triangle. So while I could name all 6 pairs of corresponding parts congruent here because of CPCTC, for writing purposes, I am not going to put all 6. I'm just going to put the 2 that I marked up here. So I know that YR is congruent to YL, and angle RYP is congruent to LYP. So now if I go ahead and I look at the blue triangles, I have 2 pairs of congruent parts. I have a pair of sides congruent, I have a pair of angles congruent. And again, I want to prove the pair of blue triangles congruent. If you look at the blue triangles here in the diagram, they share a side, YP. So YP is congruent to YP because of the reflexive property. And in the blue triangles, because I have 1 tick mark and then 2 tick marks, and I have this included angle marked up, seems like we use this one a lot, but we are able to prove the triangle's congruent because of side angle side. So we're going to do another one like this in case we are feeling a little bit uncomfortable with that one. We have another one down here. So I have given to me that I want to prove, or sorry, no, that I'm given triangle EAF congruent to triangle BDC. So I marked up the triangles in red. I highlighted the triangles in red of the pair that I was given to be congruent. And what I want to do in this proof is prove triangle EFG congruent to BCG. So I'm going to take a minute to find those triangles in the diagram and highlight them. So EFG is here, and then we have BCG. Which is here. So what I want to do first is, because I was given a pair of triangles congruent, I didn't have to actually prove them congruent, I was given that. I'm going to use CPCTC to say that we have some pairs of corresponding congruent parts. And I could name all 6 pairs of corresponding congruent parts here for reason 2, but I don't need all 6. So what I'm going to do is I'm going to look at the diagram and I'm going to see if there are any sides or angles that completely overlap or are shared by the blue triangles and the red triangles. So the first thing that's sticking out to me here is that EF appears in the red triangle as a side and in the blue triangle as a side. Same with BC. It's a side of the blue triangle is a side of the red triangle. So because of CPCTC, the red triangles being congruent, I would know that BC has to be congruent to EF, so I marked that up. Are there any other entire angles or sides that are shared by the red and the blue triangle? Well, there are no more sides that are completely shared. But there are 2 angles. So angle GEF and angle GBC are full angles within the red triangles and the blue triangles. So I'm going to say that those are congruent also by CPCTC. Again, I want to eventually prove these 2 blue triangles congruent to one another. So, do I notice anything else I can prove congruent about the 2 blue triangles? Well, nothing else is shared entirely by the red triangle, but the pair of blue triangles have a pair of vertical angles formed by those 2 segments intersecting. So I'm going to say that they are congruent, the 2 pairs of vertical angles that I just marked up, angle CGB and angle FGE are congruent because vertical angles are congruent. And then if I look at the 2 blue triangles from the diagram, I have enough information to say that they are congruent because I have 2 angles and a non-included side. So angle, side is going to prove them congruent. Remember, a non-included side is not going to be between the 2 angles that have arc marks on them. So an included side, for example, would be BG. So if BG had a tick mark on it, we would be using angle, side, angle. But the side in this particular diagram, the way it's marked up, is non-included. So we want to do angle, side. And that would prove the triangle is congruent. So that concludes the notes for today. I have posted a homework assignment that I would like for you to try tonight. And I would like for you to upload that to the assignment that I have posted on Google Classroom by 9 a.m. tomorrow. And 9 a.m. tomorrow, I'm going to post the key, and I'm going to see if we have any questions on the homework. So you can email me questions, you can post comments if you have questions. And if I can't actually type out the answers, I will make a short video and post that to the Google Classroom page so that hopefully that answers your question. But you'll get kind of some more information on that tomorrow morning when I post the key. So, first video, done.